Hello students, today we are going to learn partial fractions of class 12 mathematics. We know earlier we used to do 1 by x plus 3 by x square. We do LCM of x square, then we add the things, we form a single. Now this partial fraction is the reverse process. Suppose 2 by x square plus 1. How to convert it into two independent fractions? So let us see partial fractions. Let's see here. There were two functions are there. F of x by 3x plus 1 is f of x. X square plus x plus 4 is g of x. Here the degree of f of x is less than degree of g of x. So this is a proper fraction. If upper degree is less than lower degree, it is a proper fraction. For example, it is 4 by 15. This is less than 1. 4 by 15 is less than 1. So it's a proper fraction. It is not more than 1. Similarly, 3 by 10. In this case, it's only degree matters. In normal things, number matters. Here it is less than 1. What we call it is a fraction. We have an integer portion and we have a fraction portion. So this is a fraction portion. So similarly, if it comes to the x area, it's a single degree and this is double degree. So if the denominator is higher degree, then we call it as a proper fraction. If denominator is more lower degree, then we call it as a improper fraction. Lower degree means what? Suppose 16 by 3. Let us say denominator is lower. 3 5s are 15 plus 1 by 3. So 5 is an integer plus 1 by 3 is the fraction portion of this. Similarly, we have suppose fx is there. Qx into gx plus rx. Here Qx into gx plus rx. 16 by 3 is equal to, here rx is 5. Qx into gx, in fact, is a 5 into 3 plus 1 by 3. 15, 5 plus 1 by 3. So fx can be, when we do division, we'll have a quotient and we'll have a remainder. So all improper functions can be reduced to this thing such that rx is a proper fraction. Rx is a proper fraction. So let us say all linear functions like 3x plus 1, x plus 5, they cannot be further reduced to any factors, so they are irreducible. Suppose a quadratic equation is there, which is on b square minus 4ac greater than 0, we have two roots. If it is less than 0, there is no real root. So this is also treated as irreducible. So when we do problems, we'll better understand and we'll see this subject, how it is useful to us in our mathematics. Okay, now let us say. Before going to this, just see this example. 3 by x plus 2 plus 5 by x plus 1. The degree here is 0, degree is 1. This is a proper fraction, this is also proper fraction, and we are adding these two. When we are adding these two, what I am getting? 8x plus 7 by x plus 2 into x minus 1. This is a normal process. Now, in the partial fractions, this will be given 8x plus 7 by x plus 2 into x minus 1. Suppose I want to find integral of 8x plus 7 by x plus 2 into x minus 1. How to find out? So this first I have to convert into two proper fractions. Because this is x, here it is x square, this is a proper fraction. So first this I have to distribute. Here integral I can find out 3 log x plus 2 plus k, 5 log x minus 1 plus k. This is possible, but here to find out integration is not possible. So we convert this into this. Okay, so this is partial fraction. The reverse of this is partial. This will be given, we have to convert this. You see here, a linear function by quadratic is equal to a by linear function plus b by linear function. The roots of this. So same thing is given as root here. Suppose a linear function by ax plus b plus cx plus d is equal to a by ax plus b, b by cx plus d. We have to separate them like this. What is here ax plus b in this case? X plus 2. What is cx plus d? X minus 1. What is nx? 8x plus 7. So a we have to find out. Ax plus b is same, x plus 2. B by cx plus d is x minus 1. Because these two, these two. So once we find out A and B in this equation, so I am able to distribute this in this form. Once it comes into in this form, I can do integration, I can do binomial expansion, or I can do the powers of x. All these things can be done. Suppose if there is a square here, it is a linear function with a square. Then how I have to do square? It can have ax plus b one of the root, and ax plus b square also can be there. So a by ax plus b by ax plus b whole square. So this way, if we distribute the square, cube is there. So 1 square cube, all the three will come. A plus b plus c. So like that. These two will do some examples. Then we'll come to the third one. Let us see. Now, I am converting this into back. 8x plus 7 by x plus 2 into x minus 1. I am putting a by x plus 2 plus b by x minus 1. Okay. Once we do LCM and bottom get cancelled out, what is left out? 8x plus 7 is going to be a into x minus 1 plus b into x plus 2. When I put x is equal to 1, this will become 0. So 3 into b is equal to 15. So b is 5. If I put x is minus 2, b will be 0. So minus 2 minus 1 minus 3 minus 2 means 16. Minus 16 plus 7. This is 8 2s are 16. Minus 16 plus 7 9 by 3 is equal to 2 3. Both are minus. So that way we can get a and b. So what has just become? 3 by x plus 2 plus 5 by x minus 1. See here, 3 by x plus 2 plus 5 by x minus 1. So simple. Once, if I properly put this equation, my solving process is simple. You have to put this equation properly. Suppose here x whole square is there, then I have to put c plus c by x minus 1 whole square also in this equation, like this. Okay. Once we identify correctly, we can solve the problem. Let us say this one. 1 by x square minus 3x plus 2. X square minus 3x plus 2 is nothing but x minus 2 into x minus 1. So x minus 2 into x minus 1, I put a by x minus 2 plus b by x minus 1. Same process. And here 1 is equal to a into x minus 1 plus b into x minus 2. If I put x is 1, I get b. If I put x is 2, I get a. So a is 1 and b is minus 1. So this is the answer. So here if I have to do integration, how I can do? Bottom x square is there. I cannot do integration here. I can do here. This is log x minus 2 minus log x minus 1. Simple. So this is the purpose of partial fractions. Let's see. If the denominator contains repeated linear fractions, we have seen now, we are doing another type. What we have seen here? We have seen one type of problems where denominator is having two different linear functions. Two different linear functions. If denominator is having repeated linear function, then we will see the case. So single is a by x plus d. If the square is there, then I have to do a by x plus d plus b by ax plus b whole square. If it's to the power of k is there, so I have to put ak, a1 to ak by increasing powers of the linear function. Then I will get exact differentiation of this. Similarly, if the denominator is ax square plus bx plus c, so I have to put ax plus b by ax square plus bx plus c. Which is ax plus b by ax square plus bx plus c. So remember this. If it is not if it is a quadratic, in the above I should get a linear function. If it is only linear, I should get in the terms of power. That way we can distribute this function into 3, 2, 4 different functions. One, it is ax plus b by this. What does it mean? This is nothing but b by ax square plus bx plus c plus ax by ax square plus bx plus c. It is a 2 differentiate. If it is to the power of k, say both formulas are to be applied. So let us see some examples on this. Let us see this example. 2x plus 3 is a linear function. X minus 1 whole cubed. This is a x cube will come here. So that is a proper fraction. Degree of upper is less than degree of denominator. So cubed is there. So I have to put three functions: a by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 whole cube. So that means what? If I do LCM and do the calculation, 2x plus 3 is a into x minus 1 whole square plus b into x minus 1 plus c. So if you put x is 1, I will get c. And I'm putting x is equal to 1. These two get 0. So c is equal to 2 plus 3, 5. So I get c. Now I put x is 0. I will get a equation AB. I put x is minus 1. I will get another equation in A and B. Because c value I know 5 and 5. I replace 5 to 5 c. So these two equations if I solve, I am getting A as 0, B as 2. So what is this equation become? 2 by x minus 1 whole square plus 5 by x minus 1 whole cube. So if I do LCM as x minus 1 whole cube, what I am getting here? 2 into x minus 1, 2 into x minus 1, 2x minus 2 plus 5. So 2x plus 3. It is appearing. Same thing we can do in another form. Same thing can be done in another form. What is this form? This x minus 1, I am considering this as y. Let x minus 1 is equal to y. So what is whole cube? Whole cubed is y cube. So x becomes y plus 1. 1 comes see this side. X is equal to y plus 1. This x value I am substituting here. 2 into y plus 1 plus 3 by y cube. This is 2y plus y by y cube. That means what? 2 by y square plus 5 by y cube. 2 by y square plus 5 by y cube. The same as this. 2 by y square plus 5 by y cube. See, it is simple. Here, instead of doing A, B, C, all calculations, I am converting this into a y. If all such denominators, if this I consider as y, I get y plus y square plus y cube like that. So I can easily split the top portion. Very easy. So 2 by y square plus 5 by y cube. So both methods are possible. As you practice more and more, you will get acquainted. Let us say this whole cube is given. Now I'm putting x minus 3 is y. So x is equal to y plus 3. So x square plus 5x plus 7 by x minus 3 whole cube. This is third degree. This is second degree. So this is a proper fraction. So I substitute y plus 3 here. Y plus 3 whole square plus 5 into y plus 3. So this is becoming y square plus 11y plus 30. I can distribute y square by y cube plus 11y by y cube plus 31 by y cube. So what I am getting? 1 by y plus 11 by y square plus 31 by y cube. So I have distributed this into 3 fractions. Now I can do easily my integration or differentiation, whatever it is. Here I also, suppose I have to do differentiation. U by v. So 1 by v into du by dx minus du by dx into 1 by v square. Like that we have to do this. It is easy for me if I convert into partial fractions. Let us see another example. X minus 7 into x minus 2 by x plus 2 into x minus 1 whole square. Here this is a cubical, this is a quadratic. So this is having a proper fraction. So I put a by x minus 2 plus b by x minus 1 plus c by x minus 1 whole square. Here I don't go for x minus 1 is equal to y because there is another term here. There is another term. This is not x minus 1. So if I put x minus 1 is equal to y, this becomes y plus 3. This whole becomes y plus 3. So that my work will not be simple. So I am going by fundamental method. So when I do LCM, a into x minus 1 whole square plus b into x minus 1 into x plus 2 plus c into x plus 2. If I substitute when x is equal to 1, these two become 0. So 3c is equal to 1 minus 7 into 1 minus 2. So 6. So c is equal to 2. C is equal to 2. When x is equal to minus 2, this becomes 0. This also is becoming 0. So I am getting a as 4. So once I get a and c, b can be calculated. B minus 3. So here the important thing is how we are distributing ABC. If I put directly by c by x minus 1 whole square, If I don't put this, then my this will not be correct. Okay, let us see another example. 2x square plus 2x plus 1 by x cubed plus x square. So this x cubed plus square can be written as x square into x plus 1. So now a by x plus 1 plus b by x plus c by x square. Of course, here also I am making fractions here. 2x square can be written as x square plus 2x plus 1 is x plus 1 whole square plus x square. So I am separating here, plus has come in the numerator, so I can put x plus 1 whole square by x square into x plus 1 plus x square by x square into x plus 1. So x square get cancelled. This is 1 by x plus 1. Here x plus 1 get cancelled. X plus 1 by x square. That means 1 by x plus 1 by x square. So without going for any process, I am simplifying. Otherwise, how I can do? I will put a by x plus b by x square plus c by x plus 1. I can calculate ABC will become 1. So I am getting this answer. This way also it is possible. But here, by seeing itself, I should be able to convert into my required. If I am able to convert into my required common fractions, I can do it. But this is easier method. Now you see, denominator has irreducible factors of higher degree. Improper fraction. Improper fraction. Ax plus b. This is ax square plus bx plus c. This is an improper degree. This is more. This is more. How to do such things? It is just I have told you here. What we have seen here. 16 by 3. So this improper fraction to be converted into proper fraction. 5 plus 1 by 3. Like that in here also we have to convert it here. This is a proper fraction. This can be separated. We'll see how to do that. Suppose this is example. Here top degree is x square, bottom degree is x cube. In fact, I am supposed to divide with this. I am supposed to divide with this. But this is a proper fraction. This is x square. This is x cubed. This is a proper fraction. Let us see this proper fraction also. This is also proper fraction with ax square plus bx plus the different type of approach. It is not linear. This is not linear. This is of higher degree, but irreducible. It cannot be converted into fractions. If it is able to convert into such type, we can write down. If this can be converted into such multiplications, we can write down. It is given that this is not convertible to further linear fractions. So how to write this? A by x plus 1. Here we have seen that x square plus 2x plus 3. We have seen whenever such thing is given irreducible, I have to put ax plus b by ax square plus bx plus c. This is the way it has to be put. So let us see here. Same thing has been put. A by x plus 1 plus bx plus c by x square plus 2x plus 3. So when I simplify this, putting various x, I am getting x a is 3, b 2, c minus 1. So my function will be 2 by x plus 1 plus 3 by x plus 1 plus 2x minus 1 by x square plus 2x plus 3. Okay, now let us see this. So here we are doing examples of proper fraction, but with a irreducible in the denominator. Here, top is x to the power of 4, bottom is x to the power of 4 into x to the power of 5. So this is definitely a proper fraction. Now we have to convert into partial fractions. So this will be x square. X can be written as a by x square plus 1 can be written as a bx plus c by x square plus 1, or dx plus c by x square plus 1 whole square. See, here get one time we'll get single power, second time we'll get double power x square. If it is x cubed, we have to put gx plus a b c d f g fx plus g by x square plus 1 whole cubed also I have to put. So this is why we have to distribute. Once we understand the distribution, the process of calculation is easy. See, x into x square plus 1. Here suppose x square is there, then I have to put a by x plus b by x square plus cx plus d by x square plus 1 plus ex plus f by x square plus 1. So like that. Simple only x is given, I put a by x. So x square is this, two things will come. Because quadratic, can be reduced? No. X is, in real terms it cannot be reduced. X is equal to plus or minus I, cannot be reduced. This is irreducible quadratic equation. So once I equate the top ones, comparing the coefficient of x to the power 4, x cubed, x square, and x. Here, what is x to the power 4? This is a. X to the power 4. Nowhere x to the power 4 is coming. So a is equal to 2. Simply get a 2. This is 2x to the power of 4. Here, how much I am getting? X to the power 4 into a. X to the power 4 is coming here, and bx into x square. So we get b also, a plus b. So like that, when we compare and form the equation, a plus b is equal to 2. Because x to the power 4 is having a coefficient and b into x square. So a plus b is equal to 2. X cubed component is 0. So what is x cubed here? Is x square and 0. B x into b c x square. C x cubed is coming here. C x cubed. So c is 0. Like that we compare and write the equation. Okay. So when we solve this equation, we are getting. So this is bx plus c. Then b is 1, c is 0 because cubed here is 0 and cube here is c x into x square. No other cube is coming. So c is 0. That is it. So before going further, we will have a recapture. This is a general distribution of proper fractions. We are only talking of here proper fractions. So x minus a and x minus b, a by x minus a plus b by x minus b, whole square is equal to x minus a plus x minus a whole square. So this is where it is to be distributed. These 3 are there. So 3 will come here. This square is there, x minus b, x minus a whole square. All 3 will come here in the partial fractions. B can be anything. A by x minus a plus b by x minus b plus c by x minus a whole square. So accordingly, the value will come. Here, whole cube. So x minus b, x minus a whole square, x minus a whole cube. All forms will come in the denominator. Here, ax plus b form also will come. So bx plus c by this a by x minus c. So it is just a recapture of other things. Now let us see. 1 by x to the power of 4 minus 1. Now x to the power of 4 minus 1 is a proper fraction, no doubt. So how to convert them into distributions? So x to the power of 4 can be written as x square plus 1 and x square minus 1. Again, x square plus 1, x square minus 1 can be written as x plus 1 into x minus 1. So this is my complete conversion to irreducible. First, I have to convert into irreducible linear equations. This further is irreducible. X square plus 1 is not a real factors. So this is irreducible form. So a by x minus 1 plus b by x plus 1 plus cx plus d by x square plus 1. So similarly, this is the same is given here. Suppose 8 by x square plus 3 and x square plus 2. How I to distribute? Ax plus b by x square plus 3 plus cx plus d by x square plus 3. Whole square, single and double. Whole square, single and double. But here x square, so ax plus bx, b plus cx plus d. Anyway, it can be written. A plus bx can be written or ax plus b also can be written. No problem. Suppose this one is there. X square minus x plus 1 like this. See here, this is a less fraction. Degree is less than this, so this is a proper fraction. So how much here? X I am having 3. X minus 1, 2 powers. X square plus 4, 1 power. So I'm putting all the three separately. Then this is 2. I'm putting 2 separately. Then this is ax plus b form. I'm putting ax plus b by x square. This is the way it has to be distributed. So understood? Now see the last one. X square plus 2 by x minus 3 and x square plus 5 whole cube. So here we can get x minus 3 one time. So I'm putting x minus 3 one time. 3 one time. Then there is x to the power of 4 also is there. There is x to the power of 4. So x I am putting 4 times. Then this is cube. So ax plus b, ax plus this I have to put 3 times. So x square plus 5, ax plus b, x square plus 5, ax plus b, a2x plus b, b2, x square plus 5, a3x plus b3. So these coefficients should be separate. If then we simplify it, we will get it partial fractions, and I can do integration or differentiation of this fraction. So now we have come to improper fractions. Improper fraction. See, it is like fx is having higher degree. Here same degree. This is 12x square. This is 6x square. Same degree. What is the coefficient factor difference here? 6 2s are 12. 6 2s are 12. So 2 plus. It comes as 2 plus 3 minus x. How I got this? 3 minus x by this. Suppose if I multiply this by 2, what I am getting? 2 into minus 12x square plus 16x minus 4. So minus 12x square is same. So plus 16 plus 16x, I got this here is my 5x. 15x minus 16x or minus x. So 2 2s are minus 4 plus 1 plus 3. Minus 1 plus 4 plus 3. So if I simplify this, I will get this. 2 into minus 6 whole square minus 12x square plus 16x minus 4. And if I add these two, I am getting this way. Or we have to physically divide it. We can do it like this, we can do the division fraction. But this is easier, same grade. I can only equate my coefficients. Okay. Now this is a proper fraction. So this is a by 1 minus x plus b by 3x plus 1. So this proper fraction can be converted. So finally the answer is we get a is 1, b is 2. So this improper fraction is 2 plus 1 by 2 into 1 minus x plus 2 by 3x minus 1. So the improper first to be converted into proper fraction. Then we can distribute. Let us see here. 3x square minus 3x minus 2 by x minus 1 into x minus 2. Both are same. This is x square, this is also x square. So I can put 3 separately. A will be coming 3 because the coefficient of x square is 1, coefficient of x square is 3. So A is automatically 3 will come. So it has come where this A is 3. A is 3. So B by x minus 1 plus C by x minus 2. Here automatically fractions are given. So I can simply separate without doing actual division method. I need not do actual division because they are same degree and the coefficient is 3, coefficient is 1. So 3 plus B by x minus 1 plus C by x minus 1. So it is easy for me to calculate. I can straight away put it. Otherwise, if I put here x is 1 and x is 2, I can get A also. But by seeing itself, I can tell A is 3. Okay. Now, let us see proper. Here higher degree. Here these two are same degree. These two are same degree. Improper fraction. Here is higher degree. So I am first dividing it. X square minus 4x plus 4 with this. So what is my quotient is 8 plus 8. and remainder is 26x minus 37. So this can be written as x plus 8 plus this proper fraction. So in place of numerical, I am getting a x plus 8 coefficient. So x plus 8 plus this proper fraction we know a by this can be written as this is x minus 2 whole square by x minus 2 by x minus 2 whole square. So I can calculate a by x minus 2 plus b by x minus 2 whole square. A and b can be calculated. So this is the answer. Now it can be done any integration. So we know division method is already we know how to divide. So here x cube, here x square. I multiply with x. X is 0. So you minus at 0 plus 4 plus 4 8 minus 2 minus 4 minus 6. So 8x square is so I have to put plus 8. So you get cancelled. So I am getting this as the remainder. So quotient plus remainder by divisor is equal to dividend. Okay. Now same way x to the 4 x cube. So I am dividing. I got quotient as x minus 2 and remainder is 18. So x minus 2 minus 18 by this. Straight away I got the answer. Straight away got the answer. Otherwise, what is the second method I can having? This I have converted. Minus 18 by x cubed minus 3x square. So this how I am writing? Minus x cubed x square into x minus 3. I am writing it to irreducible fraction. So I can put a by x plus b by x square plus c by x minus 3. So total is converting into x minus 2 plus 2 by x plus 6 by x square minus 2 by x minus 3. This can be solved. ABC can be solved here. So we should be able to first reduce it to a proper fraction and a quotient. So the proper fraction to be converted as per my earlier method, depending on this. Here x square is there, so I need 2 in the bottom, x and x square. X minus is single, I need x minus 3. So now let us apply the as I told you, these partial fractions are lessons required to do integration calculation. Suppose 1 by x square minus 3x plus 2 is there. This is nothing but x minus 2 into x minus 1. So I am converting into partial fractions. So integration of this log x minus 2 minus log x minus 1 plus constant. Similarly, this integral x square by x square plus x minus 6. So this is an improper fraction. So quotient is 1. So 1 minus x minus 6 by x square plus x minus 6 is 1 outside. I'm getting x minus 6. So this minus x square should cancel. So I'm getting minus of x plus 6. So I know the partial fraction of this integral. This is integral dx. This becomes x. This minus of integral of this can be written as x minus 3 into x plus 2 or x plus 3 into x minus 2 because it is plus x. X plus 3 into x minus 2. So a by x plus 3 plus b by x minus 2. I got a and b as here 9 by 5 and 4 by 5. So this is log x plus 3. This is log x minus 2. 4 by 5 log x minus 2. 9 by 5 log x plus 3. X plus constant. Otherwise, it is difficult to calculate integration. Now, further application of partial fractions. This is the last slide. Let us see. Suppose we have to calculate integration of this. I am simply dividing in all, separating x cubed by x square, 4x square by x square, 3x by x square, 2 by x square. Now I can easily do here integrations. Or here also 1 by x square can be converted into a by x plus b by x square. This also can be further. But already I got b by x square here. I already got b by x square. So I am doing integration of x square is minus 1 by x. Integration of is minus 1 by x. By x has come here. Minus 2 plus 1 is minus 1. So which is minus 1 by x. We can easily calculate. Let us say this one. X to the power of 4, x to the power of 4, 3x cubed, x squared. From the answer, we can see that it is having a factor of x minus 1. A by x minus 1, A is 5. It is having a factor of x plus 1. B by x plus 1. It is also having a factor of x plus 1 whole square. Because when I integrate, it is becoming minus 1 by x. So x plus 1 whole square is also having. It's also having x plus 1 and x plus 1 whole square. So it's also having, so now x plus 1 into x plus 1 whole square. We got x cube. We got tan inverse 1 by x plus 1. It is having another 1 plus x square here. 1 plus x by 2 whole square. So from this answer itself, we can say so many, this is having so many factors. When I put x is 1 here, what happens here? 1 plus 1 plus 3 plus 3. How much it will become? 3 plus 3, 6 plus 2, 8. 8 minus 8, 0. So x is a 1 is a factor. I put x is minus 1, again it is satisfying. So I put again x is minus 1, it is satisfying. Again x is minus 1, it is satisfying. So like that, we have to convert them into proper these factors and we have to apply the formula. Okay. Now, I want to find the coefficient of x cubed in this. Otherwise, what is the normal method? If I have to do coefficient of x in this, what is 5 plus x, 5x plus 6 into x plus 2 to the power of minus 1 into 1 minus x to the power of minus 1. So I have to individually expand it and see the combinations of having x cubed. For in place of that, I am doing partial fraction method. So a by x plus 2 plus b by 1 minus x. If I solve it, I am getting a plus b as this minus 4 by 3 into x plus 2, 11 by 3 into 1 minus x. Now here, I can expand. 1 by x plus 2 can be written as, if I take 2 out, x plus 1 plus x by 2. So half into 1 plus x by 2 to the power of minus 1. So when I expand it, plus and minus, alternatively we get plus minus. So half into 1 minus x by 2 plus x by 2 whole square minus x by 2 whole cube, like that it goes. Because I want x cube, so I am keeping up to this point. Similarly, the second one, this 1 minus x to the power of minus 1. Here minus, everything plus will come. 1 plus x square plus x. So by seeing these two, both expansions, what are the x cubed component here? 1 by 2 into minus 1 by 2 cube. 1 by 2 into minus 1 by 2 cube into minus 4 by 3. So minus 4 by 3, 1 by 2 into 1 by 8. Plus this is 11 by 3 into 1. So if I add, I am getting 15 by 4. See here, it is easy now. I might have to simply add, that's all. But in this case, if I expand, I have to do a lot of multiplications in all the three expansions. It is easy now. Let us see coefficient of x to the power of n in this. So I am first converting into fractions. X minus 3 into x minus 2. So I converted into partial fractions. So I have expanded, 3 I have taken out, 1 minus x by 3. So 1 minus x by 3 whole to the power of minus 1, 1 plus x by 3 plus x by 3 whole to the power of n. Here also second one 2 I have taken out, 1 minus x by 2, minus I have come out. So minus 2 into 1 minus x by 2 whole to the power of minus 1. So this is the expansion of this. Minus or minus, everything will become plus. So now what I have to get? I have to get x to the power of n. What is x to the power of n here? 1 by 3 to the power of n plus 1. 1 by 3 to the power of 1 by 3 into 1 by 3 to the power of n. So here x to the power of n is 1 by 2 to the power of n. Because it is minus. So this is the combination. So if in place of n, if I put 1, if I put 2, if I put 3, I will get all the coefficients. So this is how this partial fraction is useful for us. Let us do more and more practice to get acquaintance. Once this chapter is so easy, once we do 2-3 times, So in life, we will never forget the process, and it will be handy for us in all our applications.